guys, I'm AIMAN bin ISHAK. So for my part, I want to talk about the introduction, objective, and explain about the specification of all the components. Mostly manufacturer use fully automated material handling system, which is using the conveyor belt or robots. So in our project, we use a conveyor belt, which is controlled by a microcontroller. The objective for our project is, the first one is to know how to build a system of material handling which use the conveyor belt, and the second one is to learn how to program the material handling system. Third one is to know all the specifications of all the components, and lastly is to know how to work in a team with a limited time.
Today I want to talk about the design of the box. First of all, our box is made of cardboard, transparent roofing paper, and the aluminum foil. First of all, at the top of the box, we can see the hole and the aluminum foil. We put the aluminum foil to be parallel to the hole, so that when the sensor detects the aluminum foil, the ping pong ball will drop on the hole accurately. Also, around every side of the box, there are transparent wrapping paper we use to observe the dropping of the ping pong ball during the process. At the back side of the box, there are holes that you can use to retrieve back the ping pong ball after the process ends.
So I want to make a simple explanation on all the details of the components. The first one is Raspberry Pi. This Raspberry Pi is the connect between the computer and the conveyor belt, and to control our material handling system. The second one is integrated circuit, which is to make a connection between the Raspberry Pi and the control and the computer. And this one has a voltage regulator to cut the voltage and so on. Then we have breadboard to make a connection, and together with wire jumper to complete the connection. This one is 1 kilo ohm resistor. This to resist the current is a relay. Relay is to control the movement of the conveyor belt. When we turn on the relay A, it will move to the right, and when we turn on both relay, it will move to the left, the opposite direction. Next is proximity sensor. Proximity sensor is to sense anything that pass below it. Switch, which is the first one is an open switch, and next one is an emergency switch. This is a programmable logic control. It's to control the material handling system, and we have four solenoid. This is a 3-port 2-position solenoid, and the three others is a 5-port 2-position solenoid. And the valve is, this one is single acting valve, and the other one is double acting valve.
Hello, my name is Edmund, and now I'm going to explain on our circuit diagram of our project. First is the cylinder valve circuits. Each cylinder has 2 wires. One will be connected to the 24-volt power supply, and the other will be connected to the interface circuit that will be connected to the Raspberry Pi GPIO pin. Next are the relays. The relay also has 2 wires. One is connected to the 24-volt power supply, and the other is also connected to the interface circuit, which is also connected to the Raspberry Pi GPIO pin. Next are the proximity sensors. Each proximity sensor has 3 wires, color-coded brown, black, and blue. The brown wire will be connected to the common live, the black wire will be connected to the 24-volt pin on the interface circuit, and the blue wire will be connected to the common ground. There's a 1 kilo ohm resistor connected between the common live and the 24-volt connection. Next are the 2 switches. Each switch has 2 wires, one connected to the common ground and the other connected directly to the Raspberry Pi GPIO pin. Last but not least is the DHT sensor. The VCC connection is connected to the 3.3 volt on the Raspberry Pi. The data pin is connected to the Raspberry Pi GPIO pin, and the ground is connected to the ground pin on the Raspberry Pi. There is also a 10 kilo ohm resistor connected between the VCC and the data connection.
Hi guys, my name is KINN. So right now I'm going to explain the Python code that we use to operate our material handling system. The code starts by importing all the code required for GPIO pin control, sleep function, program exit, and also sensor DHT22. A Broadcom SoC channel pin number is assigned to each and every component, and the sensor DHT22 is set up and triggered. A variable called N is assigned to account the number of ping pong balls collected in the box. This line is meant to remove the warning sign when code is run to operate material handling system, and the next line is to inform Raspberry Pi to follow the Broadcom SoC channel pin number. And each GPIO pin is identified to be used as either input or output, and the initial conditions of cylinders and relays are set up with all 4 cylinders are extended and both relays are switched off. To shorten our code afterwards, these functions are coded for sequential movement of cylinders. And again, this function is used to read the humidity and temperature detected by sensor DHT22. To start the process, a while loop is made for code to repeat till process is done. Then if condition is created, which means that the process only starts when black button is pressed. And once black button is pressed, the conveyor belt moves to the right by only switching on relay A. A statement is printed out on screen to show black button is pressed. And another while loop is used to make sure the number of ping pong balls collected does not exceed 8. And this line is used to read the humidity and temperature detected by sensor DHT22, and the next line is to print out the humidity amount. The conveyor belt continue move to the right until left sensor is triggered, which defined in these if conditions. Once left sensor is triggered, both relays are switched off to stop the conveyor belt, and the statement is printed out again, and the functions that we defined earlier for sequential movement of cylinder is run. Variable N is added by 1 after every complete set of sequential movement of cylinder, and the statement is printed out to show the number of ping pong balls collected. The process is repeats for 1 more time, and after 2 balls are collected, the conveyor belt continue move to the right by turning on relay A. This time the conveyor belt is stopped only when right sensor is triggered. Then the process is similar as just now, and after another 2 balls are collected, the conveyor belt moves to the left by turning on both relay A and B. And during the process, when red button is pressed or humidity amount is greater than 80, the process will stop immediately due to these if conditions. The conveyor belt stops moving by turning off both relays, and all GPIO pin setup is removed and the program code stops running. However, if this if condition is not triggered, a while loop is made to complete the process when 8 balls are collected. And this last few lines which define that whenever Control and C button are pressed, the process will be terminated immediately.
Now I'm going to explain on the process of distribution of ping pong balls. The ping pong balls are loaded into the distributing tubes, 4 on each side, and the black button is pressed when we are ready to begin the process. The initial setup of all 4 cylinders are in high, which means the cylinders are extended. When the proximity sensor detects the metal plate, the conveyor stops. Then the top cylinder retracts, loading 1 ping pong ball, and then it extends again to stop the supply of ping pong balls from falling down. Now the bottom cylinder retracts, releasing the loaded ping pong ball into the container. After releasing the ping pong ball, the lower cylinder extends again. After 2 ping pong balls are dropped into the box, the conveyor moves to the right to the second delivery tube. Once the metal plate on top of the box is detected by the proximity sensor there, the conveyor stops again. Similar like the other delivery tube, the top cylinder retracts, loading 1 ping pong ball, and then it extends again. Now the bottom cylinder retracts, releasing the third ping pong ball into the container. This process is repeated 1 more time in this delivery tube. The conveyor will then move back to the left to the first delivery tube to continue the process. The cycle will run for another round until a total of 8 ping pong balls are dropped into the box. In this project, we implement this distribution system to be used in factories of biscuits and cookies, where some factories produce various types of biscuits in one big pack. Therefore, using the ping pong balls as assorted biscuits and the box as the packaging, we can observe on how the production line can operate in sorting and distributing different kinds of biscuits together in a big pack with controllable amounts. Now we are going to demonstrate how the DHT22 sensor is used in the project. The code is set when the humidity reaches 80 from the DHT sensor. The whole process will stop.
Throughout this entire project, we have learned a lot about input and output devices for components such as proximity sensors, switch, solenoid, valve, and relays. We also learned a lot about material handling system, as we learn on how to make a material handling system by using Python as the programming language to run the overall operation system. The most important thing is we found that this project is very beneficial to us as it exposes us on the Python programming language, which is have been used widely in the industries nowadays.